Hi, everybody is preparing for the lab exams. Here we are going to present total lab viva voce for applied physics in a single shot. Myself, Dr. Shivanag Reddy, and let's start the thing. First, we will see the semester end examination, its duration and splitting of the marks. Basically, exam duration will be 3 hours. In a semester, we have 100 marks for the lab. In that 100 marks, 40 marks are internal. In that 40 marks, 30 for 2 mids. Average of 2 we will take 30 and 10 marks for the project report. Whereas for 60 marks will be for semester end exam. According to the regulations R22, we have to get 40 out of 100. Provided we get 14 marks for internal out of 40, 21 marks for semester end, which is out of 60. Right. So when we are writing for the 60 marks for the lab exam and exams, this is the splitting of the marks. 10 marks for the write-up and 15 marks for the experiment what we will do. Then 15 marks for the evaluation of results. Whatever we do the experiment, we will present on the paper, and based on the results and our graphs, we will get 15 marks and 10 marks for presentation on another experiment in the same laboratory course. It means you will be asked to explain or demonstrate another experiment in out of 8. We have the total 8 experiments. One experiment directly we will do, and another experiment you will be asked to demonstrate, that is for 10 marks, and 10 marks viva for concerned laboratory course. So they may ask on the same experiment or any experiment related to the laboratory. So 10, 15, 15, 10, 10. So it's a 30 plus 30, 60. So this is the allocation of the marks for lab semester end examination. So when come to the applied physics, we have 8 experiments. One of these you will get, and the list of 8 experiments will be Newton's rings, determination of radius of curvature of plano-convex lens. Second one is a single slit diffraction using lasers. In this experiment, we will measure the wavelength of a laser light. Third one is determination of energy gap of a semiconductor. Fourth one is VI characteristics of PN junction diode and zener diode. Fifth one is about photoelectric effect. Sixth one is LED and laser diode IV characteristics. Seventh one is about solar cell IV characteristics, and eighth one is the about optical fiber. We have to calculate acceptance angle, numerical aperture along with bending losses. Now we will see one by one the general expected viva questions and its answers. Let's start.
The Newton ring. When the monochromatic light is allowed to fall normally on the film and viewed in reflected light, alternative dark and bright rings are observed. These are Newton rings. And why they are circular? These rings are foci of constant thickness of air film. Since the foci are concentric circle, hence fringes are circular. What happens when order of rings increases? So whenever we are going to from the center, that is order of the ring is going on increasing. The rings get closure when order of the rings increases. Why is central ring dark? At the point of the contact, whenever we are drawing the plano-convex lens, at the point of the contact, the two interfering rays are opposite in phase and produce zero intensity. What is needed for an extended source? View the whole air film. An extended source is required. In order to observe the Newton rings, we will use microscope. So generally they will ask what is microscope. So basically microscope is an optical instrument. It is used to see the magnifying images of tiny objects. What is the function of 45 degrees inclined glass? It turns the light rays coming from extended source to 90 degrees. What if a glass plate is replaced with a plane mirror? Glass plate, so it will not get interference fringes because the intensity of light reflected from the mirror will be so great that it won't be visible and will get uniform illumination. What if sodium light is replaced with white light? Whenever we are using monochromatic source, we will get the fringes like yellow color, bright and dark. But if we use the white light, so few color rings will be observed near the center. Then what will happen if few drops of liquid is introduced between the lens and glass? The diameter of the rings will decrease because the diameter of ring is inversely proportional to the refractive index. By introduction of the water, the refractive index of this medium will change, will increase, so that rings will get decreased. What will happen if we use a lens of small radius of curvature? So generally whenever we are using the lens in the Newton rings experiment, the radius of curvature is very high. If we use the small diameter, then what will happen thereafter? So if we use the small diameter, emitter, then there is a chance of error while taking the reading. First question will be, what is the difference between laser source and filament lamp? Like monochromacity, highly coherent, non-divergent, and intensity. These are the advantages. That's why we will use the laser source in the experiment. What is a diffraction of a light? The bending of the light rays at a sharp edges or the corners. Then what is the difference between interference and diffraction? So when come to the interference of a light takes place due to superposition of two waves coming from two different coherent sources, while diffraction is due to the mutual interference of secondary wavelets originating from the various points of the wavefront. Then what is a laser? L-A-S-E-R. L stands for light, A stands for amplification, S stands for stimulated, E stands for emission of radiation. So laser stands for light amplification by stimulated emission of radiation. So what is helium neon laser? So these lasers are continuous power output laser. Helium neon laser emits a red line of wavelength 635 nanometers. So what is the effect of intensity when a single slit is replaced by double? Then intensity will be 4 times. Why is a diffraction not observed for light passing through a window? In a minima and secondary maxima will come very close to each other and merge. That is why diffraction is not observed for light passing through the window in a room. Then what is a stimulated emission? So the process in which electrons is triggered to undergo transition by the presence of photons of energy 2 minus E1. The difference of the energies between the two transition levels. What is the effect of increasing the wavelength on single slit Fraunhofer diffraction pattern? Whenever we increase the wavelength, spectrum becomes wider. Then what is laser action? To produce a laser action, one has to create a population gap of semiconductors. So what are semiconductors? So basically semiconductors are the materials which have their conductivity between conductors and insulators. Then what do you mean by energy bands? When a large number of atoms are together, as in a crystal, the energy level spread into a band. Such bands are called energy bands. Then what is a diode? Then how many types of solid materials are there? What are those materials? So based on the energy gap, we will classify the materials into 3 types: conductors, insulators, and semiconductors. Then what is conductor, what is insulator, and what is semiconductor? Already we know. Then there will be, as we told previously, there is a 2 types of semiconductors: intrinsic and extrinsic. Intrinsic are pure semiconductors and extrinsic are impure. In extrinsic semiconductors, we have p type and n type. Then we have a energy level, that's a Fermi energy level. What is Fermi energy level? The average energy of charge carriers is calculated by Fermi energy level. For a pure semiconductor, order of the energy gap will be 1 electron volt. So these are the some other questions you can try yourself, you can get. Then we have the PN junction diode and zener diode. So what is a junction diode? A junction diode is formed when a p-type semiconductor is in intimate contact with the n-type semiconductor. Then what is forward bias? What is reverse bias? Positive terminal of the power source is connected to the positive terminal of the diode. That's what we call forward bias. If we reversed it, that's what we call reverse bias. Then what is knee voltage? So in a forward biased PN junction, the voltage at which there is a sudden increase. Say for example, on a x-axis we will take a voltage, on a y-axis we will take a current, the IV characteristic. So knee voltage will be slowly changes and after that it suddenly increases. So this is the case where at a particular voltage it is sudden increase is there. That's what we call knee voltage. What do you mean by reverse breakdown? So for certain values of reverse potential applied to a PN junction, there is a sudden sharp increase in current. It's also on the same line. It will suddenly increases current. So this is what we call reverse breakdown voltage. Then what is a zener diode? So it is a specially designed diode, basically operated in reverse breakdown region. So these p-type n-type regions are heavily doped and separated by a very narrow neutral. That's nothing but a potential barrier. So what causes a reverse breakdown, especially in case of zener diode? It is due to the breakage of the covalent bond due to very high intensity of electric field. If we apply more and more electric field, there will be a breakdown. Then what is zener voltage? The reverse breakdown voltage of zener diode is called zener voltage. Then what is generally zener diode is used? Zener diode is used for voltage regulators. Then how does the bias affect the thickness of depletion layer? Generally in forward bias, thickness of the depletion layer decreases. In a reverse bias, the thickness of the depletion layer increases. Then how does the bias affect the junction resistance? It's a base, typically both are related. Whenever there is a thickness of depletion layer decreases, resistance decrease. If thickness of the depletion layer increases, resistance increase. For the making of n-type, p-type from the pure semiconductors, we require a dopant elements. So these are the pentavalent dopants. If we take a pure semiconductor, germanium, silicon like that, and if we dope with any one of the element, phosphorus, arsenic, antimony, bismuth, then we will get the n-type semiconductors. And if we dope with the trivalent impurities, we will get p-type semiconductors like boron, aluminum, gallium, indium, and thallium. So if we combine p and n, we can get p-n junction diode. Then the final one is a photoelectric effect. So what is a photoelectric effect? So it's a phenomena when electrons are ejected from the surface of a metal when light is incident on it. So basically some metals are photosensitive. So if we incident a light, they will eject the electrons from it. That's what we call photoelectric effect, and the releasing electrons are called photoelectric. Who discovered this photoelectric effect? Heinrich Hertz in 1887. In 1905, Albert Einstein is able to explain a photoelectric effect clearly based on a quantum theory. So which popular device is based on photoelectric effect? Photoelectric cell or photodiode, depends on it. What is the principle of photoelectric effect? So the law of conservation of energy forms the basis of photoelectric effect. What is this law of conservation energy here? Whenever the incident energy is there, that energy will be distributed as a work function plus kinetic energy of the electron. There won't be any loss of the energy, whatever the energy come in, it will be utilized completely. Electric formula. So this one is the given here. H nu is equal to W plus E, where H is a Planck's constant, V is the frequency of incident photon, W is the work function, E is the maximum kinetic energy of ejected electrons. Then what is the conditions for photoelectric effect? So there is a basic conditions, the emission of the electrons from a metal. At least we have to provide the minimum energy to remove the electron from its metal surface, which is nothing but the. And what is the importance of the photoelectric effect? Photoelectric effect provides the support for the quantum. So there is a different applications of there based on the solar panels, digital cams also.
Emitting diode. So here we can see a different colored light emitting diodes, and the symbol will be this. This is like a normal our PN junction diode. Rays will be out of this diode. We can see the structure of a LED, light emitting diode. Basically it is a PN junction diode. It will consist a P region, N region, that P type, N type semiconductors, and there will be an active region. It is encapsulated in epoxy resin. So whenever we supply the voltage, a light will be generated and that light will emit through it. So we will see what are the basic questions we can expect from this light emitting diode. What is LED is the first question. So basically it is a semiconductor device that emits light when electric current flows through it. And we have to remember that LEDs will work only in forward bias then. So when come to the applications, we have so many applications are there for LEDs. So these LED displays we can use in TV monitors, and then dimming of the lights in smartphone backlight, automotive lights, and in remote controls as a indicators. What is the principle of LED? So electroluminescence is an electrical and optical phenomena where material emits light when electricity flows through it. The principle is nothing but electroluminescence. Then what is this electroluminescence in LED? So basically in physics, questions will be generated from your answer only. So whenever you are answering the question, you have to make sure that whatever you are using the words or terms, you should be familiar. What is electroluminescence in LED? So when a light emitting diode is forward biased, so basically what is forward bias? In a diode, positive terminal is connected to positive terminal of the battery and negative terminal is connected to negative terminal of the diode. So in a forward bias, electrons are able to recombine with the electron holes within the device, releasing energy in the form of photon. So this effect is called electroluminescence. What are the advantages of LED over incandescent light source? Then LEDs present many advantages over incandescent light sources. It consumes lower energy, longer life will be there, and improved robustness, smaller size, faster switching, greater durability and reliability. So many advantages are there. Sometimes they may ask what is the difference between LED and laser, even though both will give same. The next one is what technology is used in LED. So basically normal diodes, it will consist a semiconducting material doped with impurities to create PN junction. So basically LED, laser diode, zener diode, all are PN junction diodes, but the doping percentages in P-type and N-type semiconductors may vary when they are made into diodes. So basically the doping percentages changes and the related information you can find here. Then what determines the colors of LED? So color of a LED, energy gap of a material. So we already know energy gap equal to H in. That can be written as Hc by lambda. Energy gap of a material is inversely proportional to the wavelength. So when energy gap is changed, then automatically wavelength will change, where H is a Planck's constant, C is a velocity of the light. So which type of band gap materials are used for LED? So basically we have two types of band gap materials. One is direct band gap, another one is a indirect band gap. So basically here we use a direct band gap materials for LEDs making, like gallium phosphide, gallium arsenide phosphide, like that. So which type of biasing used for LED diode? So basically LED diode as well as a laser diode, we always use a forward bias. So sometimes they may ask you draw forward bias on a paper and show us. So you have to get familiarity with the circuits, not only the theory, but whenever you have to present your viva, you have to be familiar with the drawing of the circuits and diagrams as well. That's all about the light emitting diode. Now we will go for laser diode. So here we can see general picture of this laser diode. So as we told previously, that laser diode is again nothing but a PN junction diode, a P-type, N-type semiconductors. Then there will be an intrinsic active region will be there through which laser light is emitted once we supply the power. And when come to the symbol, it will be a crossing will be there and light is emitting. So when we are drawing for LED, LED is simply like this. We are drawing, then laser will be the same but little different. So in this laser diode, we have so many questions on the same line, starting with what do you mean by laser and how it will work, what is basic properties, right? We will see. What is a semiconductor diode laser? It's a laser fabricated PN junction diode. So it emits the laser when it is forward biased. Then what do you understand by laser? Laser means light amplification by stimulated emission of radiation. Then it is a device used to produce monochromatic, means single color, collimated, unidirectional, intense and high coherent beam of light with small divergence. I hope you know these properties from theory concept of the lasers. Otherwise, you can cross check. Those points are very important. Then what is the principle of laser? The principle of laser depends on the phenomena of stimulated emission, and generally we can add population inversion as well. Whenever matter interact with the radiation, we have three types of phenomena are there. One is absorption, another one spontaneous emission, another one is a stimulated emission. So stimulated emission is mostly related to laser phenomena. Then what do you mean by coherence? So laser lights are coherent lights. So if the phase difference between two beams remains constant, then they are said to be coherent. Then what are semiconductors? Semiconductors are the materials which have their conductivity between conductors and insulators. Then sometimes they may ask especially what is monochromacity, what is unidirectional, what do you mean by coherence. Especially these are the properties of the laser, so it is always better to have the idea of the properties. Solar cell. So solar cell is another PN junction diode which converts light energy into electrical energy directly. It has another name, that what we call photovoltaic cell, and the phenomena what we call is photovoltaic effect. So basically here also it will consist of P-type, N-type material, and this is a PN junction diode. It will forms and it will absorb the sunlight and convert it to electricity. And here solar cells, we won't give any bias. Basically it will work in no bias mode. So we will see what are the general questions we can expect from this solar cell. So first question will be what is solar cell or what is photovoltaic cell. So basically it is a device that converts energy of light directly into electricity by photovoltaic effect. That's what we call solar cell. How this photovoltaic cell works? So basically it has to absorb the light, then generate the electron hole pairs, then the separation of the charge carriers will takes place, and that will leads to the formation of the current. So current is nothing but the flow of the electrons that has to be done here. Next one, what is the principle of solar cell? That's same thing what we did previously. That's a photovoltaic effect. Then what is photovoltaic effect? So creation of the voltage in a material upon exposure to light. That's what we call simply photovoltaic effect. Voltage. So we will see what is short circuit current. That short circuit current is the current through the solar cell when the voltage across the solar cell is zero. So when we make the voltage zero, we will short the circuit. That is nothing but the resistance in the circuit is zero. That means that the circuit is short circuit. Then we will measure the current. That's what we know, short circuit current. Then we have open circuit voltage. Whenever the resistance in the circuit may go to infinity, means it's a maximum, or we open the circuit, whatever the voltage there exists, that's what we call open circuit voltage. Then which type of semiconducting materials are used in solar cells? Indirect band gap materials are used basically in solar cells. For example, silicon. All pure semiconducting materials we can. Which type of biasing is used in solar cell? Basically no biasing mode we will use in solar cell. What are the applications of solar cells? So solar cells are extensively used in space satellites, low resistance relays for on-off operations, right? Portable exposure meters, infrared detectors, data processing industry. So many places we can use these solar cells. In this experiment, whenever we are doing, mainly we will focus on one is a efficiency, another one is a fill factor. Then what is basically this fill factor and how we will calculate? And it will be calculated by using Imax Vmax by current in load into VOC. VOC stands for open circuit voltage. ISC is short circuit current. So this IL is nothing but ISC. We can treat it as, and if we write into 100, then we will get this value in percent. The next experiment is optical fibers. Here acceptance angle, numerical aperture and bending losses. Numerical aperture and bending losses are separately two experiments. We will combinedly do as a single experiment. So optical fibers are very important in communication systems, especially in case of the internet and other things. So here what we are going to do is we are going to see what is optical fiber and what do you mean by acceptance angle and numerical aperture, and what principle this optical fiber will work, and what are the general laws takes place here. So here we can see the picture. The first picture will tell about the structure of optical fiber. It consists of a core and cladding, basically made of same type of the material like glass or plastic, and but core has the higher refractive index and cladding has the lesser refractive index. So the total internal reflection phenomena can take place and the signal will pass through it. Then this image will tell about the acceptance angle. Acceptance angle means that's the maximum angle up to which we can incident the light signal so that it will travel in the cable. Whenever we are transferring the signals, the signal has to go smooth, and at the receiver end it also will be traced back in original conditions. But if there is a problems in then the signal will get lost. What are the chances of the signal loss and all other things we will see in bending losses, especially whenever we are saying bending, micro bending and macro bending. Then things are there: scattering, absorption losses, slicing loss. So we will see what are the possible questions from here. So what do you understand by fiber optics? This is a glass or plastic material made up of thin human hair, very thin it will be. So light can be propagated to it. So basically it consists of three regions. One is core, cladding. This is a core, cladding, and then plastic buffer and outer jacket. So these mainly combinedly these two, core and clad, we will call optical fiber, and the other things as a protecting layers they will be used. Then on what principle optical fiber will work? Total internal reflection. There is a basic conditions. One is light has to travel from denser medium to rarer. Another one is angle of incidence should be greater than the critical angle. Then what is acceptance angle and numerical aperture? Basically, as we saw in the image, the maximum angle at which light entering the core is transmitted to the fiber. So without any getting disturbed, refracted, that is the maximum angle we can send the light signal into the optical fiber. That's what we call acceptance angle, and the sign of that acceptance angle is known as a numerical aperture. How is light transmitted through the fiber optic? We have different types of optical fibers, single mode and multi-mode. For single mode we will use laser light, whereas for multi-mode we will use light emitting diodes as a light signals. So when the light signal is incident on the core and makes an angle of incident greater than the critical angle of the core cladding surface, multiple total internal reflection phenomena occurs. In this way, light signal can be propagated or transmitted to fiber. Then what are the various types of losses that occur in optical fibers? So previously we saw the images. There is a different types of losses are there: absorption loss, scattering loss, dispersion loss, radiation loss, coupling loss, bending loss. Then there may be so many types of the losses. We cannot completely make it zero, but if we take care properly, we can minimize them. How do you measure the losses in optical fiber? Optic power meters and light sources will be used together to measure loss in a fiber. Then in what units do you indicate the losses? So basically losses will be indicated in decibels. What is the significance of finding the losses? Whenever we want to transmit information through optical fibers, unless we know how much a signal is getting lost in the journey, it will be difficult to set up a proper communication system. So whenever the signal is getting weak or lost, amplifiers are used in between, and that amplifiers amplify the signal and make it to go. So by studying the losses, we can make proper arrangements so that our communication system work fine. Which type of light sources used in optical fibers? So basic light emitting diodes and lasers are used. Especially multi-mode we use LED, single mode we use laser signal. With this information, I hope you can prepare the exam very well, and all the best. And we will meet in another video. Signing off, Dr. Shivanagi Reddy. Jai Hind.